lebten die Menschen noch ruhig und in Frieden. Niemand glaubte, dass es in Zukunft zu einer Bedrohung kommen würde. Nach 100 Jahren ist der Böse wieder auferstanden. Der Herr des Bösen, Graf Dracula, ist auferstanden.
Started. Turn down the volume a bit. Okay. Hope everybody's having a good day so far. I'm pretty good. A bit tired today, but just didn't sleep well, I think. But this should wake me up because today should be pretty exciting. We're gonna finish up the chess mod and maybe start on checkers. We'll probably do the lobby first, so we'll get to figure out the Unity GUI system. But I guess let's get right to it. Alright. So we have the... Where were we yesterday? Okay, yeah. We need to start doing the strict chess rules, which is we need to see if the player is in checkmate, and then we also need to check for a tie, which means that both players have no possible movement. Okay, so this would be the database win condition is a strict checkmate. So, okay, oh yeah, one thing we need to do is we need to look ahead for the next turn. So, let's see, where's that, the turn manager? Okay, so we're basically going to need a lot of information about the next turn, specifically the player, and then we would need to know the sub turn actually. That can affect some of the movement. Alright, let's first we'll supply okay, so we actually need to add this back, which is a bit annoying because I took it out yesterday because we were just going to have the turn chooser keep track of the consecutive turns, but now that we need to send that information out to other objects, it's probably better just to keep track of it in one place. And again, this is just thinking ahead to checkers because players can basically take more than one turn in a row when they hop over multiple pieces, but checker pieces can only move, they can only hop on turns after the first. So that's why we have to keep track of this here. Okay, so here consecutive turns would be 0. Okay, it's right there. And then here it's incremented. And then here we set to 0 again. Right, so let's see. So we kind of need to move this information out into a separate function so that we can call it. And we just want to take this, basically the logic out. Alright, so if it's the first turn, then we return this. Actually, it'd be if it's less than 0 here. forgot to say new. I think that's what it's complaining about. Okay, and then here. Okay, so here we keep the same player, but the consecutive turns will go up. So player equals, what is it? Okay, so just active player and then consecutive player turns. That. And then here we switch the player. And then consecutive turns is 0. Right, so now we have this little function that will figure out this information about the next turn. So you can just pull it out here. Okay, so it's always 0 here unless the consecutive turns is greater than 0. This second argument, which just signals that the turn chooser should auto assign this piece right away. So if consecutive turns is greater than 0, otherwise okay. Oh right. I guess another way to write that would just be, there we go. Okay. And then we just need to provide a remote function so that other classes can call this figure next turn. All right. Let me just assign it to the components. Keys, okay. Now we got that taken care of, so we can go back to this win condition checker. Okay, well first we need to get a handle on the remote function. here. I'll copy and paste this. The type. And then it's component keys. Next turn info. Okay. So now we just say next turn info query, and then we'll get, and that will call this function over here for us. Alright, and so now we know the player. So for here, so in the strict checkmate, okay, so first you need to make sure that the king is currently in check, and then you have to see if it has no moves. Okay. So to see if the king is in check, let's see, we call this check calculator. Okay, so that's easy. We just call this once. We're also going to need the movement option calculator, I think. Just can't spell. So we'll go ahead and get that class type. And then we just, we're going to need to copy these things down here. Okay, and then, oh, of course we need to change these component keys. So what is this? Check, yeah. And then I think this is like move option list. Okay, so first we need to loop through the current, or the next turn player's pieces. And if any of them are a king, we have to see if it's in check. I'm trying to think of the best way to structure this, but for now we'll just do this in line. Let's do that. Count. Okay, and then piece equals board pieces P, and then if piece owner player equals next turn player and piece that piece. Oh, then we need to see if it's a king. So we go database behaviors piece dot piece ID or behavior ID dot is king. So now okay, so if this piece is in check, it's the piece index, and then it's the position, which will just pass the actual position it's at. So now we need to see if this piece has any move options. So if this piece is in check and this is going to be pretty long. We'll probably separate this out, but let's see. Yeah, this is messy. Let's see. Should be a better way to do this. And then bool. This is going to be a helper function that will fill out as many values as it can from this piece variable. Turn manager. And then check for checks. Okay, so this one should make things simpler because it changes 8 arguments into 4, so it's a little better. So if the list returned is empty, which means that that piece has no possible moves, okay, then we know that this player lost. So so how we'll signal that is alright, so actually how we have to do this is if the piece owner player is first, then the game over message is the second player wins, otherwise it's first player wins. break out of this loop. And then if game over does not equal none, then we'll call this function. Okay. Alright, so now let's clean this up a bit. Let's say private. I think I did one too many braces. Is in checkmate. So basically we're just gonna collapse these if statements. Okay, so we won't do that. We'll leave these parts. Yeah, I'll leave that part there. FTL, I need to get back to that game. Okay, so this is the part we want to move, mostly, because it's super long. Okay, and then this all simplified to checkmate. This is P, and then next turn, consecutive turns. So then we can get rid of this whole if statement, which makes things a lot cleaner. Okay, so alright, I think yeah, so this should work. If any of the player's kings, which is right here, are in checkmate, and in order to be checkmate, the piece has to be in check in its current position, which means some enemy piece could capture it, and then its possible moves have to be 0, so it can't move out of the check. Okay, so I think we did that. So now we just need to do this tie, which is kind of similar. So the game will be in tie basically if no player can move. Or not if neither player can move, if this next turn player can't move. Okay, so how we'll do that. I think this will actually go for every win-loss type. So, but yeah, if game over hasn't been decided already, then we loop through all the pieces again. Okay, and basically we need to have another helper function. Has any moves. just be this part. Actually don't need that piece variable. And then we can kind of just call this other function. Which actually be if it doesn't have any moves. So yeah, I actually had this reverse. It should have been saying if count equals 0, but found that, thankfully. And it's safe to call this again because calling the next turn query doesn't actually start the next turn. It just figures out what the next turn will be. Okay, so this part we don't care if it's king. Okay, so let's actually change this. It has no moves. Okay, so if it gets this part, then has no moves, will be set to false, and we'll break out of the loop. But if has no moves is still true by now, then that means it's looped through all the pieces, and no piece has any moves, so that means it's a tie. I think the reason this doesn't count as a win for the other player, I think, is because that would kind of encourage some not fun strategies where you just try to block the other player's pieces in. Should be strict right here. Okay. I'm trying to think of an easy way to test this. Okay, well I know an easy way to test its checkmate would just be to move one pawn out and then put a rook in the front, so we'll do that first. Let's see. First I think we need to set the rules to strict chess and not capture the king. Okay, now I gotta rebuild the second player. Okay. Alright, so to check this, we'll basically suicide with this pawn. It'll take a few turns of setup, but Okay, so now once I capture this pawn, this king will be in checkmate. Oh, okay, well, should have been checkmate. Let's see if everything's set up right. Oh, okay, so this is a problem. I must have put in the wrong string, because it set the win-loss type to none. I should have checked that before. Started running. Let's see. Should be in the mod translator. Okay, so it says chess. Okay. Alright, so now... Oh, we gotta get past this screen at least. Oh, Windows. Okay, so I'll be the host. To the client. And now we can see, oh. Okay, well, let's go ahead. Oh no, I can't do that because then player 2 won't be in this mode. Oh, that's because I'm editing the build mode mod. Alright. Close that one. Host. Client. Okay, and then... Okay, so strict checkmate is what we wanted. So... Oh, okay. Game over with type first player wins. Huh. Interesting. I wonder what piece said that the king was in check. Let's go to the check calculator, and here I'll just add a debug. Let's see, string format. That's what I'm looking for. King inch. Let's see, king in check from so king index and then P and then enemy position. Just to help see it better. Okay, so let's try this again. Now we should get debug telling us what pieces, checking the king. Okay, alright, so I'll just do the same thing I did last time. So king is in check from 5 at 5-0. 1, 2, 3, 4, 5. So it says that this king is checking that king. So piece the next. Okay, well, that's not piece 5. Am I counting wrong? Let's see. King is in check. 5 at 0, 1, 2, 3, 4, 5. Okay, so I did count wrong. That doesn't make any sense. Okay, so obviously we need to look at the bishops because something weird is going on there. Alright, so it's not giving me any move options for the bishop. Correctly, only pawns and the knight can move right now. For some reason when I move this piece up it says the bishop. Let's see what happens if I do this. Huh. This time it just says game over with type first player wins, but it doesn't even say anything was checked. Doesn't make any sense. Let's see. I also just noticed that the game is not setting the debug here. Wait, it's unrelated, but I just noticed because the zero at the beginning should show the frame number. Okay, so it says game over, type first player wins. At 133. Okay, so it is this. Okay, but how could this function return true and it never printed out? What piece was checking it? So we don't need this anymore. We're having some weird null problems yesterday, I remember. Just cleaning that up. Okay, let's try it with another pawn and see what happens. Don't move a knight out. Huh. That is very strange. Oh, it's because this is an or. Why did I do that? Yeah, it should be if it's in check and it doesn't have any moves. How weird. Okay, so now I'm going to just move this out and see if it says that bishop is checking it again. Okay, no. That's good. Or did it? Oh, okay. This one's still running on the old thing. I need to rebuild the player again. Okay, build and run. Yeah, player 2 was running with the old logic, so it thought that the game was over. Okay, and now I'll try this one more time. Okay, good, we can still move. I want to get the king out so that we can, or the rook out, so that we can put the king in checkmate. Okay, so now when I capture this, it should say that second player wins because the king will be in checkmate. Okay, and it does, so phew, everything worked. Guess let's try one other thing and see what happens. This time I'm gonna leave the king in out. Oh, that is actually one other thing we need to test. Because in the strict mode, if you are in check, you have to move the king. So yeah, we'll need to add that real quick. But okay, so this time we'll do it slightly differently. This time I'll move this one pawn out so that way the king can move diagonally. So now move here. Okay, good. So it's not over. And the king, yeah, can only move diagonal because it put itself in check right there. Then I can try and chase it. Oh right, and this time the king can capture me, of course, but alright. Okay, so now let's do the other part. So basically, we just need to, for this calculate move options, we need to see if you have a king in check, then then any non-king piece has no move options, basically, because you have to move the king. So let's see. So if I guess first let's get the piece, or rather we can get the behavior. So if database behaviors args behavior ID dot, so we want to see if it's not a king. Yeah, let's pull this out. So it would be so this will return true if there's any king in check, and we just really need the player turn order. So forward. Oh, again, count. Oh, right. Count, and then if I guess let's get the piece reference. If p, oh actually it'll be if database behaviors, and then the piece behavior ID dot is king, and piece dot owner player equals player, and check query p, and then it just be the piece's actual position. Then this would return true. Otherwise, if it loops through everything and it gets to this point, then you return false. Okay, so if this piece isn't a king and any king in check, be args player. Then we skip all this. So actually it would be, so how we'll do that is if behavior is king or not any king in check, then we call this. Oh, actually get the behavior right here. Okay. I don't think that will ever lead to any infinite loops. Let's see. So let's just say I ask the calculator move options for some random pawn, but my king is in check. Let's just logically follow what the code would do to make sure there's no infinite loop. So our behavior is not a king, so it goes here and then it checks any king in check. So then we find our king piece, and then we call this check calculator, and this will loop through all pieces again. Okay, so it checks enemy kings. Alright, but when this time when it calls move option query, it always says check for checks false. So but if the other player had a king in check, oh, well, that's not possible, because if the other player had a king in check, then you would win because their king's not moving. Okay, so that is one. I wonder how the rules in actual chess work, because you could imagine that both players' kings are in check, but one player, or the active player, could actually win the game by capturing the king. But currently the game would not let them do that because they'd have to move their king. I'm not sure. Let me see if I can Google this real quick. So what happens when both kings are in check? Oh, well, okay. Yeah, actually, yeah, I think I'm overthinking it, because it's impossible for both kings to be in check under these rules, because that would require the player to move, the last active player to move into a check position, and that is not possible, so I think this is all safe. Alright, I guess the best way to see is just to test it. I think that here we should also check for capture the king, just in case something weird happens. Alright, okay. So now let's run that same. We'll do that same scheme with the rook, and then it should force me to move the king. Right, yeah, move this out again. Oh, okay, so it did cause an infinite loop, okay. Okay, so what we should do is, if the current player is not the current active player, we just shouldn't call this, because it's guaranteed that the non-active player won't have anything in check. But I don't know, the move option calculator doesn't actually know who the active player is, so I guess we'll need to I guess the safest way is to actually have another argument here. player equals active player. So I'll do this if args active player does not equal the args owner, or the behavior is a king, or there's no king in check. So the only time this would be called, or this would be skipped, is if the active player equals the owner player. Oh, it's not a king. Oops. And there's some king in check, because all those would be false. Alright. Okay, so now we need to go through, and every time this is called, we need to also pass it the active player. So we're gonna need to pass the active player also to this function, I think. I mean, the other option, of course, is to have these calculators kind of like know the current state of the board, but yeah, we actually shouldn't do that, because as we've seen in this win condition, the active player, when it's doing these checks, is actually the next player, not the current one. Okay, so I need to make another little argument structure here. Not test position, not text. So now we gotta change the signature of this everywhere, which is a bit of a pain, but king index, and here active player is active player. And turn chooser knows the active player, so that's easy. Okay, so these are all just using referencing it. So now we gotta go in any place that gets this remote function. We need to change the signature. Okay, it's only in 2 places actually. Okay, yeah, I was looking here. So new. What was the? Okay. Let's make a constructor to make that a little easier to look at. Alright. Send back, yeah, here. So new, so check calc args. Okay, and then this is the last place. And then we just need to pass this stuff. Okay, and then I need to pass active player here. Okay. Alright, so let's see. Still something wrong. Oh, okay, I missed a call. Anywhere else? Oh, missed something. No method. Okay, it needs active player here. Alright. So now let's rebuild the second player. Still left it open. Alright. Okay, so now we have no infinite loops. It's good to see. Okay, so what we're going to test for is if the game forces us to move the king when it gets in check. Okay, so now, well, at this point we could move there and there, but now once we do this, the king is going to be in check. So yeah, it says that the king can move there, but you'll notice even the pawns don't have any movement options. Okay, so it's working right. And I'll just do that. But now it should have all the same options as normal. Alright, cool. I think that was the last bit we needed. Let's see. Yeah, so now the king can't move into check. Alright. Okay, I guess I'll get rid of this. No, it's kind of a good. But you'll see it's actually only called twice in each frame, which is kind of nice. I was afraid that it'd be called a lot more because, like I've said before, it doesn't cache the results. Alright. So I think that's all the rules of chess. Let me just, I'll just look up a list of chess rules online real quick and see. Okay. Oh, I forgot about pawn promotion, actually. I thought that was, well, we were gonna have to do that for checkers anyway. But apparently you can actually choose the piece for a pawn to be promoted to. This pawn's usually promoted to a queen, but it's not necessary. I guess the only other piece that you might want to promote it to would be a knight. That's interesting, so we'll have, okay. there actually are some other special rules. Here, I'll just bring up the page I'm looking at. So there's, of course, there's this promotion, which lets the pawn, when the pawn moves to the other end of the board, it can be promoted to any piece. So this will require, we'll have to make, like, I was already going to do piece transformations because we needed that for checkers. But this one will require us to even have like some way for the player to actually choose what piece to become. Then there's this other rule, which is if a pawn moves 2 squares on its first move, and then it lands on the side of an opponent pawn, the opponent has the option of capturing that pawn. Let's see, how do you click? Oh, play. Alright, so basically how it works. Okay, that is strange. Okay, so our system doesn't actually support capturing any piece that's not on the position that you don't move to, because you can see, let's reset it. So here this black pawn is about to capture the white pawn, but it doesn't move onto the place where the white pawn was. It moves in front of it. Okay, so that is a bit, we're gonna need some special logic for that if we want to do that rule. Special rule called castling. Okay, so this castling rule is basically that the king. Okay, so that's also not supported by our system because it requires us to move 2 pieces at once. Okay, so this is an interesting rule. There's not enough pieces on the board to force a checkmate. Alright, so some of these are quite complicated. I'm not sure if we'll take so basically the 3 things we'd have to do is this en passant, which is like, the hard thing about this is that it requires capturing to a space that you don't move to. And then this castling, the hard thing for our system is that it requires us to move 2 pieces at once. And then the third is this not enough pieces on board to force a checkmate, which I'm not exactly even sure how the game would calculate that besides just having a list of all possible combos. So this, we could do all 3, but I'm not sure if it's worth the time. Of course, this rulebook says that that it's an odd but a very important rule, but I don't know. Well, I guess we can always come back to it. But yeah, we definitely will do this, the promotion, because we'll need it for checkers, and at the very least we can have pawns promote just simply to a queen instead of letting you choose. Right, so let's, I guess we can go ahead and start on that. Alright, so first thing, so we need to figure out, I guess it would be in the behavior, how the game and us mods will determine which pieces can promote. Let's see, can't find the piece behavior. Oh, I'm looking in the wrong spot, of course. There we go. So, well, I guess right now we kind of need to decide if we want to allow multiple, like promotion choice, or just only one piece, because that would decide if this is either an array or just an integer. Yeah, let's go ahead and allow multiple pieces. I mean, might as well. I don't think the only thing is that we'd have to have an extra, like, GUI pop-up that would allow the player to choose what piece to transform into. Okay, so what do we do? Promotion options. Gosh, spell that right? Yeah, I think so. Let's actually change this to, I'll just say promotion IDs. And then, let's see, so in the piece behavior for the mod, we do public int, except this would actually be a string because we just say promotion options. And then the mod translator, we go through each behavior. So that's where it does move tables. So we need to process the behaviors once, and then we need to loop back through them because for the behaviors we need to know the piece names. Let's see, do we already have a map for that? Okay, so no, it is set right here. integer, an array. It's the same length as the, oh, let's get the, I guess the logic piece behavior. Wait, what is P? Okay, right there. This is actually database behaviors, and then behavior index. Alright, so now it's the mod piece behavior, promotion options, so same length. Then we already have an I. Let's see. Actually, let's just do this. Oh no, we didn't need the index, so let's type it out. And then promotion IDs equals promotion ID is promotion index equals the behavior index map. Then okay. Oh, and then of course I need to set the promotion IDs in the actual data. Okay, I think we're all set there. Of course, there's the option that the promotion options is null, so I guess we should take care of that. So if it's null, then it's just that the logic promotion IDs is just empty. It doesn't like that. Okay. So now we have the data set up. So the promotion, it happens if you make it to the other end of the board. Let's see. Yeah, so this is just like in checkers, I think. Well, maybe I should look up the checker rules real quick to see if there's any weird things I'm forgetting. Hopefully it has a nice little list like this one. Okay. So basically, yeah, so I remember basically everything about checkers except there's if in checkers the only thing we'll need to do is that if you can hop over a piece, you have to. So we'll have to add in some more move option logic there, but we'll get to that when we get to it. Okay, so yeah, we're doing promotion right now. Actually, I just skimmed the part about promotion checkers. I should make sure it works the same. Okay, so the only weird thing about being crowned in checkers is that, well, that's what they call promotions, is that it always ends your turn even if you could still jump more, so I'll have to remember that when we get to that point. I should bookmark these pages, but I'll do that later. Okay, so yeah, back to chess. So we should just have a new promotion manager. Okay, so one thing about this is I'm realizing that both the promotion manager and then the win-loss manager both check for, let's see, let's get rid of some of these. Yeah, the win condition manager, they both check for stuff once a piece has been moved. But actually, the problem is that the order matters, because like the promotion manager should run before the win-loss manager, because if a piece is promoted, that could change the state of the next turn. And we already kind of have this problem because the match manager has to wait a frame after it gets the end of turn event. So I think yeah, so it's actually important for the match manager to call these separate functions in order. Okay, so there's a couple ways we could do that. We could either just have the match manager have a like a, what am I trying to say, a direct reference to the functions it wants to call. But it might be better if we can make like some ordered call list, so that way we can kind of we can just work within the same architecture we do for the messages and things, where these like for instance the win condition checker would just insert itself into some list to be called. So let's see. I was going to call it an ordered messenger, but that's kind of strange. But I guess it does kind of describe. Hi, Mickey. Alright, so this isn't assets. Let's see, trying to figure out how I want to structure this. Oh, not too bad. How are you doing today? Okay, well, I'm gonna think about this some more. Let's go back to the promotion manager and I'll work on this for now. Let's see. So we get the piece index. Oh, a new hoodie? That's cool. It's always nice to get new clothes for sure. So basically, let's see. Okay, so we're gonna need the board here. And then piece, board pieces, and the piece index, and then we'll need to check which. So basically, the row. So for piece, I mean, if it's the first player, it'll be promoted if it gets to row 7. Otherwise, it would be promoted if it got to row 0. So let's say if the owner player is first, then we change the promotion row to 7. And then I guess now we just need to check if the piece's board position is same as the promotion row. Actually, before we do any of this, we should make sure that the piece actually has or is promotable. Piece, I keep saying piece index. So it'd be if the promotion ID's length is greater than 0. Okay, and then so we should notify. We should have some messenger that we call when a promotion is possible, because we won't necessarily promote it right away, because the player might need to choose which piece to change to. Okay. So, and then at some other point, somebody else would call some function, or would call this function to actually do the promotion. All we'd have to do here is just have to change the behavior ID. Let's see. And then we just send piece index, and then things like the piece models would change and do any animations or whatever. That was relatively simple. Okay, so this problem I'm having here is I'm not sure. Let's see. Guess I'll just go with something easy for now. So when somebody subscribes to this list, they'll also submit a priority, and then we'll sort based on them. And then we just add it to the listener list. Okay, bye bye Mickey, thanks for stopping by. Hope you enjoy your hoodie. Listener, and then we'll sort. Okay, so we can sort with this, except I think it will create some garbage. Let's see. Comparison might be is it a delegate? That would work well. Okay, it is, so that's good. So then all we have to do is do this private sort helper. And it would return, so let's see if you return a negative integer, then it sorts it before in the list. So, and we want lower numbers to be first in the list, so I think this will be correct. So one way to make this more efficient would be to actually sort only once we need to fire the messenger. Maybe I'll go ahead and do that. It's not that hard to change. Okay, so one thing I actually do remember is if you call the use a delegate like this, it will create garbage every time you call this because it has to create a new class that contains a reference to the specific ordered messenger and then a reference to that method. So you can cache the delegate over here. In fact, you could. Yeah, I'll just leave it how it is. I was gonna say you could make this into a lambda, but. Alright, so then we decide that needs sorting here. Okay, now I'll just add a few more helper functions. Actually, you won't need to resort when you remove a listener because it maintains the order. So this just changes the priority. Sorting. Okay. I think that's everything. So now how we'll do this is the match manager. Instead of a bunch of these like win condition checkers and the promotion manager and such watching this piece moved event, they'll watch this like end of turn, I don't know how we'll call it, end of turn calculations or something. Keys, what do we call this? End of turn cal. then generate it. And then okay, and then let's see, on piece moved. Yeah, we won't. We'll just call this end of turn calcs. And then okay, so we still could get a game over. But it would come while this is like during this, so let's see if then we'd say start turn next frame. Okay. So we don't need that there anymore. And let's look at everything that reference this. Okay, so right now it's just the win condition checker. We should have another enumeration over here. That'll just help us keep track of these. So it should go first, promotions, and then win-loss check. Okay, and then we'll go back to this win condition checker. Okay, so they still will actually subscribe to the moved piece because they'll need to know what piece was moved. They just won't do their calculations right away. So you do something like this. Basically, I'll just store this value. Component, ordered messenger. Oh wait, this end of turn. And then insert. Do simple listener. I'll just use this function for now. But it'd actually be end of turn. And then the priority would be the end of turn calcs order win-loss check. Okay. And then that's strange, it doesn't. Okay, so it didn't actually care about what piece was last moved. It's good to know. Or is it just because there's... Okay. So we don't need this stuff right now, actually. And then we need to go back to the promotion manager. We'll call the same thing. In fact, I'll just copy and paste it over to make it easier. we'll actually need to keep this piece index separately. Kind of like we thought we were gonna have to do back before. And this time the calculation order will be promotion check. And then we need to get the last moved piece. Let's see, I'll just copy this over. Okay. The one thing I notice here is that we can't actually use this ordered messenger because the match manager has to kind of like, it doesn't call, because if a piece gets promoted it shouldn't call the win-loss manager right away because it needs to wait until it knows what piece we're going to promote to, which we have to wait for player input. Okay, so actually didn't need this ordered messenger, but I guess it's good to have. What we're actually going to need to do is just have two more messenger commands, kind of like we have the next turn, but one would be check for promotions and then check for game over, I suppose. Actually, we'll need a do promotion command as well. Let's see, maybe we should, instead of sending things back and forth, we can actually make this a remote function call. So right now I'm going to assume that only one piece can ever be promoted during one turn, which for now is true because only one piece can ever move during one turn. But if we ever do the this castling, where is it? Then technically two pieces move during a turn, but well, here it doesn't result in a promotion, but it could result in a promotion with mods. So but I think for now we'll just assume we can only ever move one piece during a turn. So don't actually need this. Okay, we'll leave this because we probably will need that in the future. Components. Again, it doesn't care what type it is, I always forget. So first, Did I already create any queues? Okay, so this would be check promotion. Okay. So what we'll do is the match manager. So let's change this. To G, get component, remote function. Okay. Alright, and then it's the integer component keys. Let's see, promotion query. Okay, and then so down here, instead of calling this end of turn calculations, which we don't need anymore, first we'll see if there is any promotion. Okay, so this actually needs to wait one frame, so let's see. So yeah, technically it could be game over when the piece is captured, so in that case, we can leave this here. Equals check promotion command. And if promotion possible piece is greater than 0, or actually greater than or equal to 0. Is that how I did it? Yeah. Then we need to show some GUI for choosing promotions. Well, actually, we only do this if there's more than one option, so. Okay, so I guess we should have something, another function that we can get to. Yeah, this check promotion command should just send out a list of possible promotions, probably. Well, really, it's not that difficult to find out. So let's see, all you have to do is have the board and the game database. So if database behaviors, board. This is gonna be pretty long. Promotion possible piece. Dot promotion IDs length greater than 0 or greater than 1. Then we need to show some. What was it not like about that? Oh, I need to say behavior ID. Let's just do a debug here. Okay, but otherwise we can just go right ahead and do the promotion. So let's see. That would be bool intent. So do promotion command. So we'd send the piece, and then we do the first option. This actually doesn't need to be a remote function, it's system messenger. Okay, so after that, then we'll need to say do end of turn game over. Well, I guess we could just say check game over. So for now we just won't worry about multiple choices, because we'll have to wait for the GUI to finish and everything before we actually do this part, but game over type. Oh wow, we've run a bit over. We can just do this real quick. So send, otherwise got this problem. And I think we'll actually have this function here called the on game over. And then game over check, we'll just check for game overs. But let's see. Just leaving a note for myself. Not actually call messages. Alright. I'll just figure. Okay, so we did that. I'll just say Structure game over checker. Alright, well, I guess, yeah, we better stop for now. So yeah, thanks everybody for coming out and watching. Again, I'd really appreciate the follow if you follow my stream so that you'll know when I go live tomorrow. And also subscribe to my YouTube, please, because I need subscribers so I can have a custom channel name. But yeah, just you guys watching is really, I appreciate that. So thank you very much. And I'll see you tomorrow. All right, bye bye.